Thank you. Thank you, thank you. You guys are amazing. So anyway, let's go ahead. Today, what we're going to talk about, Common Core Standards, we're going to be solving trig equations, okay? And the equations we're going to deal with today will take a little bit of algebra, whether we're going to be factoring, using trig identities. They're a little bit more complicated, but they're still not too bad, okay? 1, 5, 17. Okay, so first of all, I take a look at the first example, and it really is like two different variables. You've got a sine and a cosine. I want to change them both either to sine or into cosine. Now, you can't really change a sine into a cosine, but you could change the cosine squared. Okay, we saw that in our reading, where we can change a cosine squared into 1 minus sine squared, and that's the identity I'm going to use. So right over here on the little side note on the side, let's write that down. We know that cosine squared is equal to a 1 minus sine squared theta. Okay, I'm going to use that identity, and I'm going to use that up here to replace the cosine squared. And the whole point of doing that is then we'll get the same trig expression, which makes it so that it's like having the same variable, and we can factor, okay? So let's rewrite this as a 1 plus a sine of theta equals a 2 times a 1 minus a sine squared of theta, okay? I'm going to do a little bit of algebra, but that I can do that. That's no problem, okay? I'll go 1 plus a sine of theta equals, distribute, right? I'll get a 2 minus a 2 sine squared theta, okay? So I distribute it through. And if I were to put this in context of algebra, which, you know, do a little side work on the side. You don't have to write this down, but I'll just show you. If this were in terms of algebra, if I had a 1 plus, say, x equals a 2 minus a 2x squared, right? If I had this in terms of algebra, then the whole trick would be to get all the x's together and factor, right? Oh, you can't see that. There you go. Now you can. So instead of, you know, sines, let me just look at it in terms of algebra, okay? Let's just change it to x's so you see where I'm going with this, okay? So if I'm going to try and solve for x, I'm going to need to factor it, so I bring over the 2x squared plus x, and I bring over the 2, and I'd have a minus 1 equals 0, okay? And then we can factor that, right? Okay, right? Remember how, so I brought over the 2x squared, made it positive. I brought over the 2, subtracted 2, and made a negative 1. And then I can factor this, right? Nikolai could probably show me how to factor this, but I'll just do it real quickly, right? Yeah. So 2x, 1 and a 1, positive, minus. Everybody agree with that? So we'll do the exact process, but with signs, okay? So let's bring over the sine, the 2 sine, we'll bring that over. We'll bring over the 2, so I'll have a positive 2 sine squared theta plus a, put a 1 to help me out, a 1 sine theta. I'll subtract the 1, and I'll subtract the 2, minus 2, and I'll get a negative 1 equals 0, okay? Now, it's really the same type of expression, except for sines. Instead of x's, we've got sines, so let's just factor it, just like we would factor it in terms of x. Parentheses, 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 right? And instead of an x, 2x, we'll do a 2 sine, right? Instead of a 2x, we'll do a 2 sine theta. Instead of an x, we'll do a sine theta. We'll still do our minus 1 and our plus 1, okay? I think I'm right. I'll say that on camera. That makes a positive 2.
Yeah, but that makes a negative x.
Oh, you are right. I'll say that on camera because that should be a minus. That should be a minus. Totally right, because subtract. No. Now you're messing me up. Now you're messing me up. No, that is a positive sign. That's a positive sign, right? Don't mess me up. I'm right. Okay. Here, so bring over the 2x. This is still a positive 1, isn't it, x? That stayed right there. Right? That's x stayed right there. Subtract 2, I get a negative 1.
Yeah, but then your equation below that.
That makes a positive 2. Negative 1 makes my positive 1, right?
If I'm looking at the x in the middle, negative 1 times x is negative x.
Negative 1 times x?
Yeah.
That makes a negative 1x, right? Is that what you're saying, Ryan?
Yes.
Right. Okay, so that's a negative. So let me FOIL this.
Above that is the positive.
Yes. Yes, so let me FOIL this. 2x squared plus a 2x minus a 1x minus 1. What's that going to make?
Oh,
It's okay. It's all right. So good to go over it because somebody else might have been a little confused, and now we're not, right? Okay, so now I'm going to have a 2 sine theta minus 1 equals 0, right? It's two separate equations and a sine theta plus 1 equals 0. How am I doing? Ryan, am I doing okay now?
I have no idea.
All right. I don't want to do thumbs up yet, huh? So minus 1, I'll have a 2 sine theta equals 1. Add 1, right? Plus 1. Divide by 2 sine theta is equal to 1/2, right? All right, now over here, minus 1, I get sine theta equals negative 1. Okay, now I'm running out of room on my sheet, but I'll put the answers over here. I'm going to slide the answers in over here, okay? So answers, ready? Where's 1/2 on the unit circle? Sine is 1/2 on the unit circle at pi 6, because it's the y value.
Yeah.
And then also at 5 pi 6. Okay, right? Sine equals negative 1 is way down at the bottom at 3 pi halves. You see it? Negative 1 for sine is way down at the bottom at 3 pi halves. So this time we only got 3 answers, but all 3 answers are the answers we want, okay? Thumbs up. Sideways. Thumbs down. Okay, good. All right. At least we didn't see any thumbs down. Okay, example 2. So the problem with example 2 is the same problem. We've got sines and cosines, but we got a sine of 2 theta. But we have an identity. In fact, we looked at it in our reading that sine of 2 theta is equal to 2 sine theta cosine theta. So we need to make them the same. So the very first thing I'm going to do is I'm going to change the sine of 2 theta into 2 sine theta cosine theta. So little side note, we know that sine of 2 theta is equal to a 2 sine theta cosine theta. Okay, so let's change it so that we make everything the same, all right? So this becomes a 2 sine theta cosine theta minus a cosine theta equals 0, okay? To help me out, I'm going to put a 1 right there, just because I know the next step I want to do is to common factor. So if I put a 1 there, it helps me remember that there's a 1 there, okay? So then again, I take a look. I want a common factor. They both have a cosine in common, right? So it's common factor out the cosine. So I'll take out the cosine of theta. And then what goes inside? Well, that's going to just be a 2 sine theta minus 1, right? So take out the cosine. I'll have a 2 sine theta minus 1 equals 0, okay? All right, now what I want to do with this is just go ahead and write it down in 2 separate parts. I'll have a cosine theta equals 0 and a 2 sine theta minus 1 equals 0. Okay. Cosine is the x value and it's 0 at pi halves. And the x value of 0 is also at 3 pi halves. Okay, there's my first 2 answers. So I just found out where cosine was 0. So the x value happens at pi halves, 3 pi halves. Let's solve this. So I add the 1. 2 sine theta is equal to 1. Divide by 2. Sine theta equals 1/2. We've done this one. We just did this one. Of course, 1/2 for the y value is at pi 6. So we get pi 6. And we got it at 5 pi 6. Okay. Thumbs up, sideways, down, where are we at? Okay. Thumbs up. Okay. You guys feeling okay with this? Quinn's still kind of sideways, but that's okay. It's better than down. Turn the page. All right. All right. Okay, example 3. Cosine theta plus 1 equals sine of theta. All right, now this one's a little bit more difficult to do, okay? You know what I think I'll do on this one? I don't know what the book does, but I think I'm going to square both sides. Let's see what they do. Do they square both sides? I bet they do. I would square both sides. Where's their example? Yeah, they square both sides. Of course, that's what I would do too. Okay, so here's what I'm going to do. So I cannot change a cosine into a sine. I cannot change a sine into a cosine. But what I can do is I can change a sine squared into a cosine. I can change a cosine squared into a sine squared, right? So what I need to do is come up with a sine squared and a cosine squared. So I'm just going to square both sides. I'm just going to square both sides. I'm going to square this side, and I'm going to square this side, okay? Yeah. So if I square both sides, let's see what happens. I need a cosine squared, I need a sine squared, okay? So let's go ahead, and this will become then a cosine theta plus 1 times a cosine theta plus 1, because I squared it, so I would write it twice, right? Cosine theta plus 1 squared means whenever you squared something, it really means something times itself, right? When you square something, it really means something times itself, so I wrote it cosine plus 1, because I squared it. And then over here, sine squared theta, okay? Alright, got some work to do, but I can do that, so I'm going to FOIL. I'm going to multiply cosine times cosine will give me a cosine squared theta. Cosine times 1 gives me a 1 cosine theta. And then 1 times cosine gives me another 1 cosine theta. And 1 times 1 gives me a 1. Okay, so I just FOIL it. Cosine times cosine, cosine times 1, 1 times cosine, and 1 times 1. Okay, just FOIL it. Now, of course, that just still equals the sine squared theta. Okay, now I can combine these two, right? Put those together. So let's make it a cosine squared theta plus a 2 cosine theta plus 1 equals a sine squared theta. Okay. Whole lot of cosines. So, yeah, so let's change this sine into a cosine. I totally agree, Raul. So we change that one into a cosine. Then so of course, we know our identity is that, sine squared can be written as a 1 minus cosine squared. I'll write that on this little side. I know that sine squared of theta can be written as a 1 minus a sine squared theta. So I'll rewrite that. Okay, I've got a bit of a mess, but cosine squared. Yeah. Raul, thank you. Raul, there we go. Okay, so I'll make it 1 minus cosine squared theta. Okay, how am I doing? Okay, now everything's in terms of cosines, right? Which means I should be able to factor it, but let's go ahead and bring everything over together. So I'm going to bring over the cosine squared. I'll bring this one over. I'll add it. So if I add a cosine plus cosine, I get a 2 cosine squared theta, okay? Because I added it, right? And then plus this 2 cosine theta. And if I subtract 1 from both sides, minus 1, it just becomes 0, right? Equals 0. Okay, I'll give you a chance to catch up. So I brought the negative cosine over by adding it. So I added the cosine plus cosine, gave me 2 of them, okay? I brought this cosine over, cosine plus cosine gave me 2 of them. And then I subtracted 1, became 0. Okay, now I can common factor, right? So I can common factor out of 2 cosine of theta, because they both have a 2 cosine of theta in common. If I take out a cosine out of this one and a 2, I'd just be left with a cosine theta plus 1, right? Because 2 goes into 2 one time, and I pulled out the cosine, okay? Equals 0. Okay, I'm almost there, right? Getting pretty close. So I'm going to have then a 2 cosine theta equals 0, and a cosine theta plus 1 equals 0, right? Allie, I'm right in your way, aren't I? Divide by 2, cosine theta equals 0. Okay, that's, And then where does cosine equal 0? It's the x value. It happens at pi halves and 3 pi halves. Cosine is the x value. It happens at pi halves and 3 pi halves. So theta 1 is pi halves. Theta 2 is 3 pi halves. Okay? Minus 1, I get cosine theta equals -1. Right? And then that happens, it's the x value at pi. It happens only at pi. So that's my third angle, okay? All right. that is it. So let me go ahead and